Okay, we're going to be multiplying monomials by polynomials. In essence, what we're doing is we're using the distributive property on steroids. That's the best way to describe it. For instance, number one, people go wrong when they rush themselves. Like we discussed today, you need to slow down. So I start by distributing. So this is 4 times 2 is 8. X times x is x squared. Distribute over here. 4 times negative 7 is negative 28, and I have 1x. Done. All right, I distribute. 7 times 6 is 42, and I've got 1c. Distribute. 7 times negative 4 is negative 28. I have 1c, I have 2 c's, so I have c cubed, 3 c's. And then I go out this way. 7 times 3 is a positive 21, and I've got 1c. All right. Now I need to go back and I need to make sure it's in descending order. So I've got a negative 28c cubed, and then I have 42c plus 21c, which is a positive 63c. Okay, next one. All right, 2 times 4 is 8. I have 2 p's and another p, so p squared times p is p to the third. Distribute. 2 times negative 8 is negative 16. P squared times p squared is p to the fourth. 2 times negative 9 is negative 18, and I have my p squares. Now I need to write in descending order. So my largest are my p to the fourth, so I have negative 16 p to the fourth. Then I go to my p to the thirds, so positive 8p cubed, and then I'm left with minus 18p squared. Next one. All right, so I've got 2 distributive properties within 1. So 3 times 7 is 21. X times x is x squared. 3 times negative 4 is negative 12, and then I have my x. Negative 2 times 4 is negative 8. X squared times x is x to the third. Negative 2 x squared, so negative 2 times negative 7 is a positive 14. And then I have my x squares. And then negative 2 times 1 is negative 2, and then x squares. All right, my largest degree is this q to the third. So x to the third, so I have negative x, 8 to the third. And now I need to combine all my x squares. So 21 plus 14 is 35, and 35 minus 2 is a positive 33 x squares. And then you have a negative 12x. That's it. Last one. This is the most difficult that you'll see. They'll put in 2 variables at the same time, and it's really just the same thing. So 4 times 7 is 28. I have 2 x's, so x squared, 1y. Distribute out to the next one. 4 times negative 2 is negative 8. I have 1x, and I have 2 y's. Okay. 4 times negative 4 is negative 16. I have 1 and then 2 over here, so 3 x's, and I still have that y. And then 4 times 3 is a positive 12, and then I've got my x and my y. All right, so now we're going to start with our x's. Okay, so if I look at the x's, this is x squared, x to the first, x to the third, x to the first. So I'm going to start with this one. So negative 16, x to the third, y. And there's nothing I can combine that with. So then I go to the next one. So then I have x squared, which is here. So positive 28x squared y. Both of these are x to the first. However, this one has y squared. So this would be the next one I would write. And then I'm left with a positive 12xy. We're going to be doing a lot of practice in class with these. Okay, let's actually do one more like this. All right, let's do this one. All right, so I would start by distributing. 7 times 3 is 21. I have 2 x's and another x, so x to the third, and then I still have my y. 7 times negative 4 is negative 28. I've got 2 x's and then a y and a y, so y squared. Go out here. 7 times 6 is a positive 42. I have 2 x's and another x, so x to the third. And then I have one y and another y, so y squared. Okay, so I need to see which is my highest. So I look at my x's. I have x to the third, x squared, x to the third. So the x to the thirds are going to win. So then I look at my y squared. So the y squared's larger. So my first term would be 42, x to the third, y squared. Then I would go back to this x to the third, so plus 21, x to the third, y, and then finish off with x squared, y squared. Okay? All right, here are your practice problems. I need to see all of your work. If you come in here tomorrow and you said, I just did it in my head, I'm going to make you sit in the corner and do a worksheet. Just saying.